Okay, 5-6 radical expressions. So, as we talked about the other day, the we talked about at the beginning, in 5-5 everything worked out nicely, right? We could take the fifth root of 243. What happens when they don't work out nicely? So the product property of radicals says if I'm taking the nth root of two numbers that are multiplied together, a and b, then I can separate it apart and take the nth root of a and the nth root of b. Well, same thing if I'm dividing, I could separate it apart and take the nth root of a divided by the nth root of b. Now, in that case, remember all roots need to be defined because I don't want to be taking a radical of 0 or something I can't do, or the negative square root of something. That's what that means. Okay, so when it says simplify, and you'll notice these all say simplify, what does that mean? Well, the index n is as small as possible. We're not going to change the index yet, but eventually this chapter I will show you how we change the index. The radicand, that's the guy under the radical, contains no factors that are nth powers of an integer or a polynomial, meaning I can't take something out. Okay, I'm taking a square root and I have 16 under it, I don't leave it in. I get it as much out as I possibly can. No fractions in the radicand, and no radicals in the denominator. And yes, I will show you how to fix all of those things. Okay, so look at number 1 there. It says simplify 25 a to the 4th, b to the 9th. Okay, what's my index? What's the... There's no number there, we assume him to be a 2. Okay, can I take the square root of 25? Yeah, it's 5, right? And can I take the square root of a to the 4th? Yeah, it's 2, right? A squared. But now, Houston, I have a problem. I have b to the 9th. And 9 doesn't divide by 2 evenly, so we don't put it as a decimal, though. Watch what happens. I'm going to just draw it all out so you can see it. 1, 2, 3, 4, 5, 6, 7, 8, 9. The index tells me how many I'm going to group together. Think about our A's. We had 4 A's. My index says put them in groups of 2, and I had 2 groups of A's. There's where that A squared comes from. Does that make sense? I'm going to do the same thing with the B's. I'm going to put them in groups of 2. 1 group, 2 group, 3 groups, 4 groups. That guy is left over. So I have 4 groups of B's that get to come out, but one poor lonesome B has to stay inside the radical. So essentially you're finding the next smallest number divisible by 2, right? It would be 8, there was 1 left over. All right, look at number 2. It says simplify 3 times the cube root of 56 y to the 6th z to the 3rd. All right, that 3's just hanging out front, and he's going to stay hanging out front. Look at your chart. Do you have 56? Can I take the cube root of 56? No, he's not on there. So instead what I'm going to do is I'm going to write a prime factorization of 56. So we're going to do a factor tree. All right, so give me 2 numbers that multiply to 56.
8 times 7.
8 times 7. Thanks, Colin. Can I break 8 down further? 4 times 2. So my prime factorization of 56 is 2 times 2 times 2 times 7, yeah? 2 times 2 times 2 times 7. I may have said too many 2's. Okay, what's my index? 3, right? This guy right here is my index. It says I'm going to group them. Same thing, has to be 3 in a group. Well, I have 3 2's that are the same, so they can be in a group, and they get to come out of the radical. So I still have that 3 hanging out front before. I have a group of 2's that come out. I'm going to leave some space so I can deal with my variables. Put your index back. What has to stay in the radical? The 7 does. Then I have 6 y's. Two groups of 3 come out, so I have y squared. And the z's. 1 z gets to come out. And 3 times 2 is 6. So we end up with 6 y squared z times the cube root of 7. You have to have that 3 in that index still in there. Okay, questions on that before we try the next one? Okay, number 3. We have the 4th root of 1 over 81 times c to the 5th d to the 4th. I'm going to rewrite it so that that guy's all on the top and the 81's on the bottom. And my rule up here said I could separate it into each having their own radical. All right, the 4th root of c to the 5th, d to the 4th. How many go in a group? What's my index? 4. 4 c's in a group, 1 left over, all the d's in a group. So I have a group of c's that come out, a group of d's that come out. Who has to stay? 1c. And hopefully this is the 4th root of 81. Is that one on our chart? What's the 4th root of 81? 3. So that guy worked out nicely because it said we can't have any fractions in the radicand. I don't have any fractions under my radical. It also said no radicals in the denominator. Guess what? We fixed it so there's no radicals in our denominator. You could also write this as 1/3 if you would like. Either way is fine with me. Okay, well that one worked out nicely, right? Is it always going to work out nicely where my radical doesn't have a fraction or there's no radicals in the denominator? No. So, if we need to fix those things, we need to do what's called rationalizing. Rationalizing the denominator gets radicals out of the denominator and fractions out of the radicand. Okay, so look at number 4. I have have the square root of y to the 8th, x to the 7th. Let's simplify that guy as best we can. What's my index? 2, right? So this is the square root of x to the 7th over the square root of, oh, that's a y, sorry. Y to the 8th over x to the 7th. How can I simplify the square root of y to the 8th? Y to the 4th, right? Divided by 7x's, 4, 5, 6, 7. I'm going to put them in groups of 2. So I have 3 groups with 1 left over. All right, now my rule said I couldn't leave a radical in the denominator. So I have to do what's called rationalizing the denominator. Could I give the denominator something so that that radical goes away? Give him another x, right? If I give him another square root of x, he would be the square root of x squared. Would you agree with that? Now, if I do it to the denominator, where else do I have to do it? The numerator. And that's because this guy, anytime I have the same number on the top and the bottom, he's essentially 1. And if I multiply by 1, do I change numbers? No. So whatever you do to the denominator, you have to do to the numerator. Okay, so watch what happens. I have y to the 4th square root of x divided by x cubed times the square root of x squared. I switched those two guys together under one radical. Well, what's the square root of x squared? X. Alright, so this guy is y to the 4th square root of x over x cubed times x. And x cubed times x becomes x to the 4th. So what do? We moved the radical to the top by rationalizing. So we multiplied enough to get the radical out of the denominator, and whatever we do to the denominator, we have to do to the numerator. So essentially it moves that radical to the numerator and increases the denominator exponent. Okay, let's try another one of those. So look at number 5. Let's separate it apart. I have the square root of a to the 4th divided by the square root of b to the 3rd. What's the square root of a to the 4th? A squared. And now I have 3 b's on the bottom. So I get b. One group of b's comes out, one b has to stay. B root b. I can't leave a radical in my denominator, so what should I give my denominator so it goes away? Another b. So I'm going to multiply by the square root of b. So I get a squared, square root of b, over what? What'd you say, Shina? B squared, perfect. I had one B outside. This guy becomes square root of B squared. And that's just one more B, so B times B is B squared. Whoa, sorry. Okay, questions on rationalizing? Questions on anything so far? All right, we got a blank. You can add only like radical expressions. That means the indices. That's plural for index. Indexes is. So the indices and the radicands must be the same. Okay, so look at number 6. It says 3 root 45 minus 5 root 80 plus 4 root 20. All right, the index is all 2 on all of those, so that's good. However, I have a 45, an 80, and a 20. I can't add those guys. So what I have to do is I have to see if I can break them down, and maybe they become the same radicand. Okay, so I'm going to factor tree each one of these guys here. Okay, so 45. What are two numbers that multiply to 45? 5 and 9. What if you said 3 and 15? That'd be okay, because we're just trying to break it down into its prime factors. And 9 breaks down to 3 and 3. So is there something that can come out? A 3. All right, so I have a group of 3s that can come out, and I also have a 3 out front. I'm going to write it all out so you can see it. So there's the 3 that was out there, the 3 that comes out. What has to stay? The 5, right? We don't want to look at the 9 anymore because we broke him down. Okay, how about 80? How do you want to break down 80? 8 and 10. If you would have said 2 and 40, that's fine too. 8 and 10. 5 and 2. 2 and 4. 2 and 2. I'm running out of room. All right, I have a negative 5 out front. How many groups of 2s came out? 2 groups of 2s. What has to stay? The 5, right? Okay, there's that 4 still out front. Let's break down 20. 4 and 5. If you said 2 and 10, that's okay. What gets to come out? What has to stay? So I had a group of 3s that came out of the first one with the 3 out front. So that guy ends up being 9 square roots of 5. And then I had a 5 out front already with a negative sign. Times 2, that would be 10. Times 2 more, that would be 20. So this guy is minus 20 square roots of 5. Plus 4 times 2 is 8 roots of 5. Now, think about them as adding and subtracting like terms. They're all root 5, so we just need to add and subtract the numbers out front. So what's 9 minus 20? Negative 11, right? Plus 8 more. Negative 3. Okay, try letter B. See if you can do it. Break them all down. Factor tree them. See if you can get the radicands to be the same. Now, they don't all have to be the same number, but break them down as small as you can. Okay, so the square root of 12 breaks down into 2 root 3. The square root of 48 breaks down into 4 root 3. If you notice, I did 4 and 12, and then I did 4 and 3. As soon as, you don't have to go all the way down to the 2's. So as long as you get 2 of the same things to come out, if they're bigger, that's perfectly fine. Does that make sense? So I got 2 4's. You also could have gotten 4 2's. So 4 root 3. And then 27 breaks down into 3 root 3. So 4 plus 2 is 6. 6 minus 3 is 3 roots of 3. Okay, questions on adding and subtracting? Okay, we have a few more examples to go over, so turn the page. You can multiply radicals by using FOIL. Okay, so just like we did with binomials. First outsides, insides last. I'm going to write everything out to show you, and then after you see it, you can start skipping steps if you need to, okay, if you want to. The thing when you multiply radicals is you multiply, if they're outside of a radical, they get multiplied together. If they're under a radical, they get multiplied together. So, I have 2 root 3 plus 3 root 5 times 3 minus, I'm going to put a 1 out front just so we can keep them straight. Root 3. Alright, so first outsides, insides last, right? So, 2 root 3 times 3. That means the 2 times the 3 outside can be multiplied together. So that guy becomes 6 square roots of 3. Okay, and then I have 2 root 3 times a negative 1 root 3. Alright, these two guys are outside radicals, so 2 times a negative 1 is negative 2. Square roots of 3 times 3 is 9. The 2 times the negative 1 gives me the negative 2. 3 times 3 gives me the 9. Alright, so that was first, and the outsides. Now I'm going to do the insides. Plus 3 root 5 times 3. Just like the first one, he doesn't have an inside of a radical. So I'm going to do 3 times 3 is 9 root 5. And finally, 3 root 5 times negative 1 root 3. Ooh, I wrote too big. That's okay. Outside the radicals is 3 and a negative 1, so that becomes a minus 3. Inside the radicals, or under the radicals, is 3 and 5, so square root of 15. Okay, now check it. Is there anything that we could simplify? Any radicals you could break down? Any square roots you can take? Square root of 9. What is the square root of 9? 3. So this guy becomes 6 root 3 minus 2 times 3, or 6, plus 9 root 5 minus 3 root 15. 3, 5, 15 is going to break down into 3 and 5. So none of the radicands are the same. That's all we can do. Want to try B? Go for it. Do B.
Ms. Snowden?
Yeah.
What number on the worksheet do you want us to do?
Hold on, let me check. I want to do all of them except for that you don't have to do the word problems again. So 1 through 33.
Okay, thank you.
You're welcome. Okay, so when you FOIL it out, you end up with that. First up, you get 16 root 4 minus 28 root 2 plus 28 root 2 minus 49. What happens to those 28 root 2s? They cancel out, right? Okay, so that's nice. And what do you know about 16 square root of 4? Square root of 4 is 2, and 2 times 16 is 32. So 32 minus 49 gives me negative 17. So look at what happened. We multiplied 2 binomials together and they had radicals in them, but we ended up with a number. What do you notice about these two guys? Close, right? One of them's a plus and one of them's a minus. Where did we see that before? In factoring, right? When we were factoring the difference of squares. Remember that? In fact, we can see that. This is the difference of squares. That guy's a perfect square. And that guy's a perfect square. So this guy right here has a special name. He's called a conjugate. So A root B plus C root D and A root B minus C root D are called conjugates. If they're exactly the same, the numbers are the same except for the sign in the middle is different, they're called conjugates. The nice thing about conjugates is we can use them to rationalize the denominator. Okay, so look at number 8. And I want to show you something before I actually do it. Alright, so if you look at number 8, the cool thing about when we multiply conjugates together is we'll always end up with a number. Okay? It gets rid of radicals. So, if I look here, we have a radical in our denominator, right? This guy right here has two terms. When we did it on the other side, we just multiplied by a root 3, right? Okay, well watch what happens if I were going to multiply by a root 3. I would have to distribute so that I get 4 root 3, don't write this down, it's not right, minus the square root of 9, and the square root of 9 is 3. Would that fix our denominator? No, that won't fix our denominator, okay? We just moved our radical from here over to here. So instead, what we want to do is we want to get rid of that radical in the denominator completely, and we know that if we multiply by a conjugate, anytime we multiply by a conjugate, you'll always end up with just a number. So instead of rationalizing by root 3, we're going to rationalize by the conjugate. So it looks exactly the same, except for the sign in the middle is different. So 4 minus the square root of 3, I'm going to rationalize by 4 plus the square root of 3. And whatever you do to the denominator, you have to do to the numerator. Alright, so I'm going to start with the numerator and I'm going to FOIL everybody. 2 times 4 is 8. 2 times root 3 is 2 root 3. Root 3 times a positive 4 is 4 root 3. Root 3 times a root 3 is square root of 9. Now, on the denominator, anytime you multiply by a conjugate, that middle term will always cancel out. Okay, we are forcing the O and the I, the outside and the inside terms, to cancel out, just like we did up here. It will always cancel out. One will be positive and one will be negative. I'm going to write it out, but then we can get to a point where we can skip it. So 4 times 4 is 16. 4 times root 3 is plus 4 root 3. Negative root 3 times a positive 4 is negative 4 root 3. And negative root 3 times a positive root 3 is a negative square root of 9. So, just like we were hoping the 4 root 3's cancel, one was positive and one was negative, and now I'm just going to simplify some things. I can't cross out between the numerator and the denominator. Don't do that. Okay, there's plus signs. This is a grouping symbol, so you have to simplify the whole top. What's the square root of 9? Yep. So I have 2 root 3 and 4 root 3, so I have 6 roots of 3 plus 3 and 16 minus 3. So I get 11 plus 6 roots of 3 all over 13. Two plus 4. Yeah, Kate.
So, would you use conjugates anytime there's more than one term?
Yes, perfect. So anytime there's more than one term in the denominator, always use a conjugate. Yeah, good question. Okay, so look at letter B. There's 2 terms in my denominator. One of them is a radical. So what's the conjugate of the denominator? Four. Yeah. 4 plus square root of 3. This one's kind of nice because we can just distribute the 7. There's only one term in the numerator. 7 times 4 is 28. 7 times root 3 is 7 root 3. If you're not sure, go ahead and FOIL the whole thing out. But I will guarantee you that we're trying to force those middle terms, the O's, to cancel out. So I'm just going to first and last this guy. 16. And then I get a positive 4 root 3 and a negative 4 root 3. So they cancel. Minus the square root of 9. It will always be a minus, too, by the way. So I get 28 plus 7 root 3 all over 16 minus 3, which is what we were hoping for. 28 plus 7 root 3 all over 13. Okay, questions on anything we did so far for today? Okay, so let's look at your worksheet really quick. Numbers 1 through 6, those ones you're just making a factor tree, they're just numbers. Okay? Seven through 10, those ones you have variables with them, okay? If there's somebody that can't come out, he stays in the radical. 11, 12, some of these in here you may have to rationalize. From 11 to 15 you may have to rationalize. Just depends on what's left in the denominator. Let's see, 16 you're multiplying, 17 you're multiplying, 18, you're adding and subtracting like radicands, so get them as small as you can and add them together. 21, 22, 23, 24, 25, 26, 27, you're foiling all of those. Okay, remember that means you have two of them of the exact same thing, so you're foiling them. And then down at the bottom, 28 through 33, that's where you're going to use your conjugates. So like 28, you're going to multiply by the square root of 5 plus 2. Okay? You don't have to do 34 or 35. Those are the word problems. Okie dokie. All right, questions on anything else?